All right, here's example 2 from chapter 2, section 1. Again, we're looking at transformations to quadratic functions right now. So in the last example, we looked at horizontal and vertical translations. So moving your graph up and down and left and right. In this example, we are going to look at reflections, and we're going to look at vertical and horizontal stretches and shrinks. So before we look at these problems, let's go back and look at our journal. And what I want to look at is the different ways that you cause reflections and horizontal and vertical stretches and shrinks. So again, remember, these rules, these transformations are caused the exact same way as they were with linear functions. So remember, with reflections, remember this is flipping your graph over either the x or the y-axis. And this is caused by making either your entire function negative or the input to your function negative. So just like with linear functions, an x-axis reflection, so this is a reflection going up and down, so vertical. Remember, anything vertical means that you're making a change to the entire function. So with this vertical reflection, we are making our entire function negative. For a reflection in the y-axis, remember that's flipping left and right. So that's a horizontal flip. We're flipping over the y-axis. That involves making our input negative. So we just replace x with negative x. Okay? So vertical reflection, vertical going up and down is making your function negative. Horizontal, which is going left and right over the y-axis, involves making your input negative. Now when it comes to horizontal and vertical stretches and shrinks, again, exact same thing. Let's look at vertical shrinks first. Remember, vertical stretches and shrinks are either pulling your graph up or pushing it down. A vertical stretch is if you pull your graph up away from the x-axis, and a vertical shrink is if you're pushing it down towards the x-axis. Because this is a vertical transformation, it involves making a change to the entire function. So this is where you're multiplying your entire function by a constant. Now a horizontal, this is where you're either stretching away from the y-axis or shrinking towards the y-axis. And this involves multiplying your input by a constant. Now, remember, with vertical stretches and shrinks, it's a stretch if your constant is greater than 1, and it's a shrink if your constant's between 0 and 1. Horizontal, this is where it gets kind of inverted. Okay, you look at the change that's being made, and you're actually, to figure out the factor, you actually have to take the inverse. So the factor, it's a horizontal stretch if this value that you're multiplying your input by is between 0 and 1, it's a stretch. And if it's greater than 1, then it's a shrink. We'll look at a couple of those examples where you actually have to, to figure out your factor, do the 1 over a. So we'll look at an example like that. But this is just a review to show you that all of your transformations are made the exact same way. So let's look at this example right here. So let's look at part A first. So we're going to look at the transformations made from our parent function x squared represented by g. And then we're going to graph. Now again, the graph's going to show us what these changes look like. So let's look at the first one. We've got g of x equals negative 1/2 x squared. So the first things that you want to do is figure out exactly what changes have been made. So we want to go ahead and we want to look at what form it's written in. So here we can see that this matches the form negative a x squared, right? Where a is a constant. In this case, a is 1/2. So remember, the negative is always going to relate to a reflection, and the a value is always going to be our shrink or stretch. Okay, so here we again look at the changes. We see that this negative 1/2 is what multiplied our entire function by. So let's go ahead and see what these are now. Now, because the graph, we're taking our entire function and making it negative, that's an x-axis reflection. We're flipping over the x-axis. And because a is less than 1, that's a vertical shrink. So look what happens. Our graph flipped over the x-axis, and this curve has become wider because we're pushing it towards, it's shrinking towards the x-axis. So with a vertical shrink, your graph, your parabola becomes wider. Okay? So first, notice the two changes we saw were the negative and multiplying our entire function by a constant. So that was a x-axis reflection, and it was a vertical shrink by a factor of 1/2. You always want to make sure that you include the factor, because that number is going to tell you if it's a stretch or a shrink. Now let's look at our second one. Here we've got in parentheses 2x squared plus 1. So here we notice that our changes, notice the difference between A and B. Here we were multiplying x squared by 1/2. That's how we knew that this was a vertical shrink. Here we're just multiplying our input by 2. Notice, see the parentheses show that just our input's being multiplied by 2 and then squared. Okay, so we're multiplying our input by 2, and then we're adding 1 to the entire function. Again, not adding 1 to the input, but because it's outside of the parentheses and the squared, we're adding 1 to the entire function. Okay, so here we know that the 2x, this is going to be a horizontal stretch or shrink, and adding this k value to the function means that it's going to be a vertical transformation. Now remember, with horizontal stretches and shrinks, to figure out if you've got a stretch or a shrink, you have to take your a value and take the inverse of that to find your factor. So here, our a value is 2. So what we do is we take 1 over a, and that becomes our stretch or shrink amount. So because a is 2, that means we have a factor of 1/2. So that's a shrink. We have a horizontal shrink by a factor of 1/2. And with k equals positive 1, we translated up 1 unit. So let's look at what that looks like. So here's our horizontal shrink by a factor of 1/2. Notice this graph has shrunk closer to the y-axis, so it's narrower, and it's shifted up 1 unit. So again, a horizontal shrink by 1/2 because we take 1 over our a amount, and then a translation up 1 unit. So go ahead now and give these 3 a try right here. Just like you did on the previous one, go ahead and please write in all 3 answers, but label them 4, 5, and 6. And all I want you to do is describe the transformations. So look at each function and tell me what transformations have taken place from our parent function to our new functions g. So you should have 3 answers in here, and each answer should be the description of the transformations for each of these 3. Go ahead and enter those in the text box now.